Alright guys, this is week 2 of Science Activate, and today we are going to be looking at these questions. Our first question is from an experimental analysis, experimental design portion of the ACT. And so in question number 1, we're looking at this passage. And so if we look, they're testing a hypothesis that the presence of bubbles in cans of various liquids would affect the roll time, the time it took a can to roll. So they're rolling it from here to here, and they're looking at the time that it takes down an incline. And so in experiment 3, they added 1 liter of flat tasting beverage to an empty 2-liter clear plastic bottle and sealed the bottle. They rolled it down, no bubbles formed. They shook the bottle, causing bubbles to form, and set the bottle aside. So they're looking at bubbles, and 15 minutes later, some bubbles were still visible, but after 2 hours, no bubbles could be seen. And so this question number 1, is asking, in experiment 3, what is the most likely reason the students used the plastic bottle rather than an aluminum can? Now, compared to an aluminum can, the plastic bottle does what? Rolls more rapidly down the incline? Well, that's not what experiment 3 really says, so we can kind of eliminate that one. Most likely, why did they do it? Is it because it made bubbles in the liquid easier to see? Well, a clear plastic bottle, they definitely state clear plastic bottle, so that would be one reason. Let's put a mark on that one. Contain a greater quantity of liquid. That's kind of the same. I mean, they put a liter. I've never seen a liter can before, so maybe that one's it. It had thicker walls and was less likely to break. I don't know about breaking an aluminum can. That's probably not the right answer. So we're looking at either B or C. So if you were designing this experiment, which one of these would be the reason? Was it B? If you're looking at bubbles and you're trying to figure out the presence of bubbles in cans of various liquids affects the roll time, you might want to be able to see those bubbles. And so B is our best answer according to this question. All right, question number 2. We're looking at experiments 1 and 2 in the same experiment now, or 2 different experiments in the same question. So the students added 1 liter of a liquid in experiment 1, tap water containing no bubbles, to an empty can, sealed the can and found its roll time. Next, they added 1 liter of tap water to a second empty can, sealed it, shook it, and immediately found its roll time. They repeated these procedures using soapy water containing many bubbles and a carbonated beverage that contained no bubbles and that tasted flat, having lost most of its carbonation. The results are shown in table 1. So tap water had the same times there. Soapy water, after they shook it, made more bubbles. It took more time. And flat tasting beverage, after they shook it, they also had more time. So that's one experiment. Look at experiment 2. The students added 1 liter of the flat tasting beverage to an empty can. They sealed the can, shook it, and set it aside. 15 minutes later, they found the roll time. So this one was after 15 minutes. And this one was immediately. So right away, 15 minutes after this one. So this is still a little bit increase, and this one's still a little bit increase. And what are they? Do we know what the cans are? We didn't say what the liquid was. It was a flat tasting beverage. So it was a flat tasting beverage. So they waited 15 minutes after shaking, and it still was a little bit increased. So that is a very good, interesting topic. Let's look at the question. Based on the results from experiments 1 and 2 in the following trials, in which of the following trials before shaking were the average speeds of the cans the same? Let's see. In which of the following trials before shaking were the average speeds of the cans the same? So speed is going to be about the same as the time, because they're all moving the same distance. So our average speeds being the same, let's look at this. Before shaking, we've got this time right here is 175, this time right here is 175, and this time right here is 175. So that is trial 1 and 3, and we have trial 3 and 5 all the same. And so which were the average speeds of the cans the same before shaking? And that looks like 3 and 5. J is our answer. Alright, so this is now question 3. In experiment number 2, we have the result of shaking a can of flat tasting beverage was what? So we're looking at experiment number 2, and they sealed the can, shook it, and set it aside, and then 15 minutes later they found the roll time of the can before and immediately after shaking it. That's in trial 4 there. And 2 hours later, they found the roll time of the can before and immediately after shaking it. That's trial 5. So 2 hours later, this was 15 minutes, this was 2 hours later. So the results there, and we want to look at the shaking the can of flat tasting beverage. Why did they want to do? Did the number of bubbles decrease? Did the mass of the can increase? Did the roll time of the can decrease, or did the roll time of the can increase? Well, it looks like in all of our cases, in both of these cases, we went from 186 to 196 and 175 to 193. And so if the number of bubbles decrease, we can't tell that one. The mass shouldn't have changed. We didn't look at mass in this question. We're looking at roll time. So did the roll time decrease or did the roll time increase? Well, it looks like the roll time before to after shaking increased, so D is our correct answer. Next one. Number 4, in trial 5. We're looking back at trial 5 now. Remember, this was the 2 hours later. They found the roll time of the can before and immediately after shaking it. Is it likely that bubbles were present in large numbers immediately before the can was shaken? Well, what do you guys think? 2 hours later, if you've shaken the can of soda and you've shaken it and it started lower, if it started way lower, that's kind of interesting. If you remember from trial 1, this was 1.75, so was the tap water in trial 1. So that's kind of interesting there. But let's think about this. Do we think that the bubbles were present in large numbers immediately before the can was shaken after 2 hours of sitting still? Well, we've got a low time which suggests there weren't a lot of bubbles. So based on the results of experiment 1, the bubbles produced in trial 4 probably lasted less than 15 minutes. I don't know that we have any evidence for that. Yes, based on the results of experiment 1, the bubbles produced in trial 4 probably lasted for more than 2 hours. I don't know that we have much on that. No, based on the results of experiment 3, the bubbles produced in trial 4 probably lasted for less than 2 hours. Or J, no, based on the results of experiment 3, the bubbles produced in trial 4 probably lasted for more than 3 hours. That doesn't make any sense. So I think our answer is H. Based on the results of experiment 3, the bubbles produced in trial 4 probably lasted for less than 2 hours. And if this was 2 hours later, then it should have fewer bubbles. So the number of bubbles are going to be smaller. They're not present. So no, they're not going to be present. H is our correct answer. Question number 5 is another one on this same experiment. I know we're beating a dead horse, but suppose that in experiment 2, 2 hours after the completion of trial 5, the students had measured the roll time of the can of liquid without first shaking the can. Based on the results of trials 4 and 5, the roll time would most likely have been what? So if they did not shake the can at all, after shaking, what do we think? Is it going to be less than 1.86 seconds? Maybe. Is it going to be between 1.86 and 1.93? Well, this was 15 minutes, and this was 2 hours, and we're looking at 2 hours after that, trial 6, we'll say. And so this was 1.86 to 1.96. This was less there, considerably less, to 1.93. And then if we're doing it before shaking, this got smaller. So we're probably less than 1.86. We're probably not bigger than 1.86, especially not between 1.86 and 1.93. let's see, probably not going to be there. Probably not going to be between 1.94 and 1.96. Definitely not going to be greater. I'm going to say that A is probably our best answer. If especially after 2 hours here it was 1.75, after another 2 hours it's probably going to be less than 1.86. So 5 is our correct answer. We'll just double check here. Yeah, B, J, D, H, and A was our correct answer. So good job, you guys, and we'll see you next week.